Bismillahirrahmanirrahim. Today we are going to solve Cambridge O-Level Physics Paper 4 Alternative to Practical ATP. For the session of May-June 2024, we have the subject code 50454 and the variant of this paper is 41. We have 1 hour for this paper and this paper is carrying 40 marks. We are allowed to use calculator in this paper. So we're going to start our question paper from the question number 1. Question number 1 is that a student find the volume of a small glass marble by 2 different methods. Part A, method 1. The student placed 6 small digit glass balls by the side of a meter roll as shown in the figure 1.1. Make sure that there are no gaps between the balls. As you can see from the figure, there is no gap between the balls. Okay, there is a point A indicated and there is a point B indicated and meter rule is used. First point is, take readings on the meter rule of the position of point A and B as shown in the figure 1.1. Give your reading to the nearest 0.1 centimeter. Okay, you need to note down the readings between A and B. So position of point A is exactly 10.2. You can see from the square, and position of B is 19.7. So you have to write 10.2 centimeter and 19.7 centimeter. Okay. The length, second part, the length L on the figure 1.1 is the distance between point A and point B. The average diameter D on one ball can be found by using the equation, that is L is equal to 6D. You can see that this is between A and B is L. So you can find L by subtracting length of B minus length of A, that is equal to 19.7 minus 10.2. And the answer is, for the value of L is 9.5 centimeter. Now you need to calculate the value of L, that is equal to 6D, and the value of D would be L by 6. And you have just calculated the value of L, that is equal to 9.5. So you need to substitute here 9.5 divided by 6. You get the value of D, that would be equal to 1.58, or you can round it off to 1.6 centimeter. So this would be your final answer. Moving to third part, the average volume of V of one glass ball using this method is given in the equation. Okay, calculate V. So we need to substitute the values 3.14. The value of D we just calculated, that is equal to 1.6 cube, and divide by 6. After solving it, we get the answer, that is equal to 2.1 centimeter cube, because this is volume. So this is one way. We have calculated the volume. Now method 2. The student pours the water into a measuring cylinder. The volume of water in the measuring cylinder V1 is shown in the figure. Write down the reading of V1. You can see from the table, and this is 25, this is 26, and the reading would be 27. So we can write 27 as our answer over here. Okay. Moving to its second part, the 6 glass balls are carefully added to the water in the measuring cylinder. The new readings on the measuring cylinder V2 is shown in the figure 1.3. The volume Vt of the 6 balls is given below. Vt is equal to V2 minus V1. So what would be V2? Okay, we just calculated V1. You can see that it is 35, 36, 37, 38 and 39. So V2 is 39 and V1 we have calculated in previous page, that was 27. Subtracting it, we get the value that is 12 centimeter cube. You can write in the answer space as well, 12 centimeter cube. Now calculate the average volume V of one ball using this method. Give your answer to the nearest 0.1 centimeter cube. Okay, so we know that we can find them by dividing it by 6 because we have 6 balls and total volume is 12. So dividing it by 6, we get the answer that is 2 centimeter cube. So this would be our answer. So this was a very easy part. Moving to part C of this question, suggests whether method 1 or method 2 give the more accurate value for the volume of the ball. Explain your answer. Method giving more accurate value is method 1. Okay, why I have chosen method 1? Because method 1 is using meter rule, and meter rule has the least count value is 0.1 centimeter or 1 millimeter. On the other hand, method 2 is using measuring cylinder, and measuring cylinder has the least count of 1 centimeter cube. So the least count of meter rule is smaller, so that's why it gives us more accurate or more precise answer. So that's why I have chosen method 1. So you can write in the explanation, through method 1 diameter can be measured accurately up to 1 millimeter, and method 2 volume can be measured accurately up to 1 centimeter cube. So method 1 is more accurate. Moving to its D part, the student uses the 6 balls to find the average mass of one ball using a small beaker and a top pan electric balance. Describe the method the student used. Okay, simply we can write, first we can note down the mass of empty beaker through top pan or electric balance and call it as M1. Now fill the beaker with 6 balls, and after filling those balls in the beaker, now we again note down the mass and we can call that mass as M2. Now subtract M2 and M1. After subtracting M2 and M1, we can divide them by 6 to calculate the average mass of one glass ball. Why we are dividing by 6? Because we want to take the average and total balls are 6. So first we have just calculated the mass of empty beaker, then we have calculated the mass of the beaker that contains 6 balls. After subtracting those masses, we get the we divide them by 6 to get the average of one ball. So this is how we have write our answer. Moving to question number 2. A student investigate how the temperature of the surrounding affect the rate of cooling of water. A. Part 1. The student pours 100 centimeter cube of hot water into a 250 centimeter cube beaker. Uses a thermometer to take the temperature of the water at time t is equal to 0 second. The thermometer reading at time t is equal to 0 second is shown in the figure 2.1. Record the temperature of the water at time t is equal to 0 in the table 2.1. You can see from the above that this is the value. So this is 71 and this is 72. So you need to write your first reading when the time is 0 second as 72. Okay. Moving to a second part is that the student then records the temperature theta of the water every 30 seconds for 240 seconds. The results are recorded in the table. You can see from 30 to 240 seconds. Okay. Before taking each temperature reading, the student carefully stirs the water in the beaker. Explain why. Student stirred the water so that the heat of the can be spread evenly. So you can write that to ensure an even temperature throughout the water or heat is evenly spread. You can write either of one point. Moving to its third part. Third part is that calculate the average cooling rate C1 of the water for the first 90 seconds of the experiment. Use the reading in the table 2.1 and the equation C1 is equal to theta naught minus theta 90 divided by T, where theta naught is the temperature of the water at 0 second, theta 90 is the temperature at 90 second, and T is the time of 90 second. Give the unit for C1. So we know that starting we have the value of 72 and at 90 we have the value of 66. So 72 minus 66, and how much time is taken? That is 90. So we can divide it by 90. 6 by 90, you get the answer that is equal to 0.067 Celsius per second. So C1 value is 0.067 and the units are Celsius per second. Now moving to its fourth part. Calculate the average rate C2 of the water for the final 90 seconds in the experiment. C2 is given that 150 minus 240 divided by. So at 150 the Celsius is 64, at 240 the Celsius is 61. So you need to subtract 64 minus 61 and divide it by 90, because the temperature difference between time difference between 240 and 150 is 90. So 3 divided by 90, we get the answer that is equal to 0.033, and the unit for it would be Celsius per second. So this was again a simple question and very simple calculation that you can extract from your table, which is already given in the paper. Okay, compare your values of C1 and C2. Explain any differences in these values. Okay, you can see the value of C1 that is equal to 0.067, and you can see that 0.033 is the value of C2. So we know that C1 is greater than C2 because less drop in temperature as the temperature becomes closer to the room temperature. It is simple that whenever the time passes, any hotter thing tends to closer to the room temperature, so its temperature changes less compared to earlier change in the temperature. So that's why C1 is greater than C2, because less drop in temperature as the temperature becomes closer to the room temperature. So this is how we have just compared it. Moving to part B. Part B is that the student repeat the procedure described in A part 1, but this time he places the 250 centimeter cube beaker inside a larger beaker containing ice water. The arrangement is shown in the figure. Now the surrounding will affect, because first surrounding was without any cold water. Now this hot water is placed inside the ice water, so the temperature change will happen more rapidly because the temperature difference is very far. Very great. Okay, the student reads the temperature theta of the hot water, records the reading and immediately starts the stopwatch. Table 2.2 show the temperature theta at time t is equal to 0, 30 seconds, 60 seconds and 90 seconds. Calculate the average cooling rate of the hot water for the 90 seconds. Use the reading in the table 2.2 and the equation C3 is equal to theta naught minus theta 90 over T. C naught has the value of 75. We can see theta 90 has the value of 57. We can see 75 minus 57 divided by 90. Subtracting those values, we get the value of 18. Then 18 divided by 90, it would be equal to 1 by 5. And we can, after dividing, we get the answer that is equal to 0.2. So the C3 value is 0.2 and its unit are Celsius per second. So this was again the same practice we have did earlier in earlier parts. Okay. Now describe how C3 differs from the C1. Explain your answer. Yes, C3 is greater than C1 because more energy is lost to the colder surrounding compared to C1. So that's why rapid sudden change of energy happen more quickly. So that's why C3 has greater value. Next part. The recorded readings show that experiment is not a valid comparison of C1 and C3. By referring to the result recorded in table 2.1 and table 2.2, explain why this is not a valid comparison. We can say that these both tables don't start with the same initial temperature, so it is not the fair comparison. So you can say right that in both tables the initial temperature is not the same. Next part. State one variable that should be kept constant to make a valid comparison. So you can write either of it. Volume of hot water should be kept same or room temperature should be same. So you can write any one of it. So that's how we are completed question number 2. moving to second last question of this paper, that is question number 3. A student measure the focal length of a lens. Figure 3.1 show the operators she uses and the position of the lens when a clearly focused image is formed on the screen. You can see that lamp, illuminated object, convex lens holder and the screen. The student places the screen at a distance d is equal to 60 centimeters. This is a very important information we can use in a head question from the illuminated object. Places the lens between the object and the screen so that the lens is very closer to the illuminated object. Move the lens slowly away from the illuminated object like that until a clearly focused image is formed on the screen over here. Measure and record the distance x on the figure 3.1. So you can calculate by putting your scale over here and note down the distance between here and here. So, and the distance should be equal to 4.8 centimeter. Next part. Figure 3.1 is drawn to a scale of 1/5 full size. Choose your answer to A part 1. Calculate the actual object distance from the lens. Okay. So we can see here this is 1/5 of the full size. So if the distance is 4.8, then the actual distance we can get by multiplying it by 5. Why? Because this is 1/5 of the full size. So 4.8 multiplied by 5, you get the answer that is equal to 24 centimeter. Next part. Deduce the image distance V, the distance from the lens to the screen when a clear image is seen. You know that V plus U is equal to D. What is V? V is the distance of image from the lens and U is the distance of the object from the lens. So D minus U. We know that total distance is 60 and U we just calculated in previous part, that was 24. So 60 minus 24, we get the answer that is equal to 36 centimeter. 60 was earlier in the question that D is equal to 60. This is the total. So we subtract this to get this value. Okay. Moving to its B part. B part is that figure 3.2 show the shape of the illuminated object and figure 3.3 show the image seen on the screen. Figure 3.2 is this and figure 3.3 is image. So we can clearly see that the image is inverted and also the size of the image is magnified. It is larger than its actual size. So you can write these 2 points. Now part C, first part. The student moved the screen away from the illuminated objects and repeat the procedure for values D is equal to 70, 80, 90 and 100 centimeter. Table 3.1 show the values recorded. Add your values U and V from A second part and A third part to table 3.1 on page 12. This on page 12. Complete table 3.1 by calculating the value of U cross V for each value of D. Give your answer to 3 significant figures. So okay, this is our table. You can see that the value of D and U We have just calculated in previous part the value of u is 224 and the value of v is 36. By multiplying it, you get the value of 860. I have rounded it off to the nearest 10 value to all those value, so we can plot this graph easily. So you can get these value by multiplying 21 into 49, that is 1030. Then 19.5 into 60.5, that is equal to 1180. Then 18.6 into 71.4, you can get the value that is equal to 1330. And the last 17.8 into 18.2, you get the value 1460. Okay, use the grid provided in the figure 3.4 on the page 13 to plot a graph of u cross v on the y-axis. Okay, now this is clearly mentioned. We have to draw on y-axis u cross v and against d centimeter on the x-axis. You do not need to start your axis from the origin at 0, 0. Draw the straight line of best fit. Okay, I have started this from the value of 50 as d was starting from the value of 60, 70, 80, 90. So I have started with 50. You can see 50, 60, 70, 80, 90 and 100. And on y-axis u cross v, where the value is 860 to 1460, I have started with 850. Then it's 900, 950, 1000, 1050, 1100, 1150, 1200, 1250, 1300, 1350, 1400 and 1450. Now I have already plotted this graph. This point, first point was at 60 and 860. So this was the first point. Then all those points are plotted. Okay, so this is how I draw the best fit line. It doesn't need to cross all those points, but it does need to show the effect of all those points. Okay, now for the third part, the focal length f of the lens is numerically equal to the gradient of the line. Calculate the gradient of the line, show all your working and indicate on your graph in figure 3.4 the value you use. So we have to indicate those value as well. I have selected those 2 points, that is equal to 63 and 905. So this is our point, first point, that is equal to 63 and 905. And the other point I have chosen is 80 and 1175. This is 80 and 1175. I have been asked this question in my previous paper of 42 for this year in the May-June session, that how we can calculate the gradient. You can calculate the gradient by selecting any of 2 points. You can take other than these 2 points. So your answer would be remain same. So you don't need to worry. You can take any those 2 points. I have just selected those 2 points, but you can take any of 2 points to get the answer. So I have selected 63. Oh, this is 80 and 1175. And this is 63 and 905. So you can select any 2 points other than these 2 points. Okay, if you want. Oh, I just selected this. Now I write those points over here, so I can calculate gradient. The formula for the gradient is y2 minus y1 over x2 minus x1. That would be equal to 1175 minus 905 dividing by 80 minus 63. You get the answer, that is equal to 270, and our answer is 15.9 centimeter. Examiner has written in the answer key that any answer between 14 and 70 would be considered correct. If your answer come 14.1 or 14, it would be considered correct, or your answer come 16.8, 16.9 or 17, it would also be considered correct. Any value between 14 and 17 would be considered correct, including 14 and 17. Now the part D. The lens manufacturer state that the focal length of the lens is 15 centimeter plus minus 10%. Decide with the calculation whether your value of f, we just calculated 15.9, f agrees with this statement and tick the box that show your answer. So first we need to find that 10% of 15, that would be 15 multiplied by 10 by 100, and it is 1.5. So if we add 15 plus 1.5, it should be 16.5. If we subtract 15 from 1.5, 15 and 1.5, it would be 13.5. So any value would be considered correct of the manufacturer accuracy value, and our answer was 15.9. so that lies between those value, 16.5 and 13. So we check the first box that was written, my value for the f agrees with the manufacturer statement, because it is within the range of 10 plus minus 10%. Okay, so this is how we have completed this question. Again, this was easy question, but you need to attempt very carefully, and most importantly for P4 papers, you need to read your question very carefully and slowly, so you can't miss any point of it. Moving to the last question of our paper, that is question 4. Plan an experiment to investigate how the thickness of metal wire affects its resistance. The resistance of a wire can be found using the equation R is equal to resistance of wire, potential difference across the wire, and current in the wire. It means that this formula that is deduced from the Ohm's law, R is equal to V by I. The following apparatus is available: 6 lengths of metal wire and each of different thickness. Very important this point. An ammeter, because we want to compare the thickness of the wire with the resistance. An ammeter is used to measure current, and a voltmeter used to measure voltage. Power supply, that is used to give the power to the circuit. Several connecting leads, and a micrometer. Why were you using micrometer? To find the thickness of the 6 wires that have the different thickness. Other operators normally available in school laboratory can be used. In your plan, you should draw a circuit diagram. Okay, very important information. Show how you will use this operator. Okay, I have drawn the circuit diagram. You can see that the wire is attached with voltmeter and ammeter and the battery, and this is switch, and I have connected ammeter correctly in the series and voltmeter correctly in the parallel. Now explain briefly how to carry out this investigation. Okay, we will carry out this investigation by taking 6 wires of different diameters, but their length should be kept constant and they should be of the same material, so it would be a fair comparison. This is very important point. The length of the wire and the material should be kept constant to for the sake of fair comparison. Okay, state the key variables. I have stated. Draw a table. Table is showing readings of 1 till 6 wire, then the diameter of these 6 wire, which we will calculate from with the help of micrometer. Then we switch on for first type of wire. Then we note down the voltage and current, then divide voltage with current, we get the value of resistance. Okay, enter any readings in the draw a column, and you are not required to. Okay, we have just draw the columns showing all those necessary figures. Explain how to use these reading to reach a conclusion. We can reach a conclusion by dividing voltage and current, then compare those resistance with the value of diameter, and this comparison will tell how the thickness of the wire impact the resistance value. So I have plotted the graph, and for x-axis we have plot thickness and or you can say diameter, and for y-axis it would be resistance. Okay, and its pattern should be like that because the value of resistance varies inversely to diameter. Okay, you can write that. I'm going to read it. Take 6 wires of different thickness, but for the fair comparison, the length and material of all these 6 wires should be kept same or kept constant. Okay, this is very important point. Only thickness is the criterion. Thickness should be with. Now measure the. Okay, this is the wrong page. Now measure the thickness of the wire with micrometer. Connect ammeter and voltmeter. So measure the thickness of the wire with the help of micrometer. Now connect ammeter and voltmeter and switch with the help of the wire. Close the switch and note down the reading of thickness of the wire, current and voltage in the table, which we have shown in the first page, that diameter, current, voltage and current, and divided by them. Divide voltage with the current to get the value of the resistance. Repeat the same procedure with wires of different diameters, and in each case note down the value of current, voltage and calculate the value of resistance in each case by dividing voltage and current. Now compare the readings to see how the thickness of the wire does affect the resistance. Then plot a graph of thickness of wire or diameter against the resistance. So this is how you're gonna compare resistance with the diameter by showing. Okay, so this is how we have attempted this paper. Hopefully you have the understanding of this paper after watching this video. If you do have any queries related to the paper, you can ask in the comment section. Do not forget to subscribe my channel and also share with your friends and community who needs help and support in physics, chemistry, maths or even in IGCSE papers. So keep supporting, and thank you so much for watching this video. Allah Hafiz.